Welcome to yet another session on linear regression. Linear
Thank
regression
you.
is one of the most applicable topics in quantitative methods where we're going to learn the relationships that exist in companies between two or more variables. Now, the relationships that we're going to illustrate only happen in 5 good ways. So I'm going to use these graphs to illustrate the relationships. So we have relationships that are upward sloping. These relationships are positive. Now, positive relationships are epitomized by relationships like advertising and sales. As you increase one variable, the other variable also increases. So it's a positive relationship. Supply, for instance, government has just increased the floor price of maize, so many people will be willing to supply more because of the higher price. As one variable is increasing, the other variable is also going to be increasing. This is called a positive relationship. Now, these two positive relationships, there's what we call a strong relationship and a weak relationship. So to show you whether it's a positive relationship, we use the letter R, which stands for the coefficient of correlation. To look at the strength of the relationship, we use R squared, which is called the coefficient of determination. So we also have a negative relationship, which is downsloping. Like has been explained here, same if the dots are close to each other, it means a strong relationship. Our R squared, which is the coefficient of determination, will be more than 50. If the dots are apart from each other, it means this is a weak relationship, meaning the R will be less than 50, the R squared. So these are the relationships that will exist. Figure 1 is showing you positive relationship and figure 2, whereas figure 1 is a strong positive, figure 2 is a weak positive. Figure 3 and figure 5 are negative relationships where figure 3 is a negative strong, negative weak. And when there is no order, there is no relationship at all. Figure 4 shows there being no relationship. So the regression equation is represented by an equation y is equal to a plus bx. A is the cutting point of y. It's called the y-intercept, where it cuts the y. So to understand regression more, you need to understand what a dependent variable and independent variable is. So our goals in this topic is to establish the concepts of linear regression in a probabilistic framework. It is also used in hypothesis testing with linear models to test whether the regression line is significant enough. We're also going to learn how to estimate the error in the regression. So regression, by definition, is a technique used for modeling and analysis of numerical data. It makes use or exploits the relationship between two or more variables. If you're dealing with two, it's called a linear regression. More than two, it's called multiple regression. So regression is used for prediction. If you want to predict, for instance, if I'm going to advertise with a sales budget of 10,000, you're able to know how much sales revenue I'm going to have. It is used for estimation. It is used for hypothesis testing and for modeling causal relationships. Causality, especially when you are doing research, is best by regression. For instance, the relationship between one's work experience in a company and their productivity. You can use a regression equation, or how much time you spend to study in your performance. That is a causal relationship. Impact, the relationship, all these topics that you're going to do later on to do with regression have to do with how one variable affects the other. So there's what we call the dependent variable. this depends on the independent variables. So these independent variables have two other names that you can call them. You can call them predictor variables or explanatory variables. And this one is the outcome. So if you're dealing with sales and advertising, this could be your sales, the outcome, and this would be the advertising. They are independent. Advertising doesn't depend on sales, but sales depend on advertising. So the Y is your response variable, in short, the outcome. So why linear regression? This is the only model that is able to give you how much of these indicators x1, x2, and x3 influence Y. Of course, later on, in a deeper version, we're able to determine how much of these variables specifically have an impact on the outcome, what contribution each of them has. So this you'll learn mainly in your final level, as I'll be taking you in the research, quantitative research methods. For now, you need to understand that this is mainly preparing you for research. Most students that I take in research and I took in quantitative methods, I find it easy to relate because they're able to apply this in their final report. So I gave you the regression model, which is given by A plus BX. Now, this is not any different from this formula. BO is the constant, it's the same as your A. The B1 is a slope, which is the change in Y over change in X. So I'm going to take you through 9 basic formulas that are very easy to come by. Then we will look at a question together. So for you, you need to understand that regression is used to ascertain the strength using our R squared, which is the coefficient of determination, which is given by SS xy divided by SS xx times SS yy. So our regression coefficient of determination is able to tell you how much of y is influenced by x. For instance, if our R squared is 0.9, it means 90% of y was as a result of x. If we had 0.4, this means 40% of y is as a result of x. It's a moderate relationship. If our R squared is 0, it means there's no relationship at all. Examples of relationships: sales and advertisement, age and BP, length of experience, and productivity in an employee in a workforce. Then the R, I say it stands for the coefficient of what? Correlation. You can have a positive or negative relationship. If your slope is negative, it means downsloping. Your B is positive, it's upsloping, it's a positive relationship. So here, it is able to tell you the type of relationship, whether you have a positive or a negative relationship. And finally, it's a prediction. It's used to predict whether the relationship will give you a certain future amount of sales, probable BP, or output. So the key formula we're going to consider is y is equal to a plus bx. Now, we need to understand how to calculate this by understanding the sum of squares. Sum of square xx is simply summation of x to the power 2 minus summation of x to the power 2 over n. So we're dealing with x's only. Sum of square yy, we have y's everywhere. Sum of square y to the power 2 minus summation of y to the power 2 over n. Here it's supposed to be y. Then xy, summation of xy minus summation of x times summation of y over n. A is the y-intercept, so the mean of y, which is summation of x y over n minus the slope times the summation of x over n. Then the slope now is found by, how do we find the slope? Are we together so far? How do we find the slope? So the slope will be found so to find the slope, it is summation of xy over summation of xx. Our RI is summation of xy times summation of xx times summation of yy square root. So this looks like a jargon, but I'll simplify it. Okay, I'll take you through an example. So suppose we have the values of x and y. We have 1, 2, 3, 4, 5, and y we have 1, 1, 2, 2, and 4. So we are asked to draw what is called a scatter diagram. So to draw a scatter diagram, we have x 1, 2, 3, 4, 5, and y we have 1, 1, 2, 2, and 4. So we're going to use the coordinates 1, 1, we put it here, 2, 1, we put it here, 3, 2, put it here, 4, 2, put it here, and 5, 4, put it here. So here we get our 3 marks for this. They ask you to comment. What is your comment? It is showing a positive relationship, which is strong. The dots are close to each other. You're able to tell what type of relationship is existing here. Then the next, they'll ask you to calculate the regression equation. We're going to come up with the regression equation. So we firstly need to fill in these values of x, values of y. xy, we're going to multiply. 1 times 1 is 1, 2 times 1, 2, 3 times 2, 6, 4 times 2, 8, and 5 times 4, 20. When we add here, we get 35, 37. When we add here, we get 10, and we get 15. So x squared, we are squaring this 1, 4, 9, 16, and 25. These are these values here. Then we square this one here, 1, 1, 4, 4, 16. So when we total this, we get 26. And the n is the number of pairs we have, which are 5. So with these pairs, which are 5, we now want to calculate the sum of square xx, sum of square yy, and sum of square xy. So like I said, xx, we have values of x throughout. So summation of x is 55. Summation of x is 15 to the power 2 over n. So 15 times 15 divided by 5 is 45. So 55 minus 45 is 10. So this is called the sum of square xx. Sum of square yy is summation of y squared minus summation of y all squared divided by n. So summation of y squared is 26, you put it here. Summation of y is 10 to the power 2 is 100. 100 over 5 is 20. So 26 minus 20 is 6, which is here. Then sum of xy, you have xy throughout. So xy is 37, you put it here. X and y, 15 times 10 over 5. So this is 30. So 37 minus 30 is 7. So these are preliminary calculations that are important. After you find the sum of square xx, yy, and xy, you can summarize them here down. Xx is 10, yy 6, xy is 7. Then now this will be easy for you to calculate the rest. This will be easy for you to calculate the rest.
Sorry, Collins, I've got a question. On the just the page before, we're saying, like, for example, just the last bit, we're saying 15, what's that?
15 times 10.
Yeah, we are saying over n, which is the 5, but
yes.
we are not really dividing by the 5.
We are. What is 3 into 15? 5 into 15
That's
is 3.
5.
Yeah, for 5 into 15 is 3. 3 times 10?
Yes.
30. So 37
30.
minus 30. This is a 7 here.
Oh, okay. All right.
Okay. So after getting these figures here, the slope, now it is easy to calculate the slope and now error, everything else, because these are very key. So our slope is sum of xy over sum of xx. So xy was what? 7. Xx is what? 10. So 7 over 10 is 0. What? 7. So this is how we get the 0.7. All right, then our error is xy over xx times yy. So 7 over 10 times 6, the answer is 0.903. Okay, then we go to our r squared. We just square this answer. We're going to get 0.816 here. So remember, this in percentage is 81.6% of y is influenced by x. Then to find our a summation of y over n, all right, we had 10 over 5 divided by, subtract b. B we just calculated as 0.7. Then summation of x was 15. 15 over 5, which is n. So it will be 2 minus 2.1, which gives us negative 0.1. So now we substitute in the regression equation. We found our a as negative 0.1 here. So we put where there's a, negative 0.1. B we found as 0.7. So where there's b, you just put 0.7. That's all. Then you leave x and y because it's an equation. So the second question was, find or predict y where x is 10. So where there's x, you put 10. So here you're going to have 0.1 plus 0.7. Where there's x, we put what? 10. So what are we going to get as a final answer?
Is it 6.9?
Yeah, 6.9. Correct. Great. Then they'll ask you to find our r and r squared. R stands for what? Coefficient of correlation. So we found 0.903. What does this mean? It's a positive relationship. Then when you square it, the name changes to coefficient of determination, r squared. What does this mean? It means 81.6% of y is affected by x. So our r is important in that regard. So this is how the first part of regression is supposed to be sorted out. So regression is very easy if you're able to understand what we have just discussed. So regression is also used for hypothesis testing. So we've done the prediction. I'm going to take you slightly into something else, but before I go, anyone left behind? Maybe we can try a question together where we're going to come up with a regression equation. Okay, so let me try to erase this. And here we have y, and here xy, then x squared and y squared. Y squared. So suppose this is 10, 6, 8, 5. Okay. So how do we get this column here? What do we get in here? What do we get here?
20.
20.
20.
24.
24.
24.
And here?
48.
48.
40.
40.
And here?
4. 16.
16.
36.
36. 64. Yeah. Okay.
100. 36. 25.
Then we total up. Let's total up. What do we get here?
20.
20. This is called summation of what? Of x.
X.
Then
20.
the next one. This is called summation of what?
Y.
Of y. Which is what?
31. Is it 31?
31. Then the next one is what? Summation of xy.
132.
132. Then next one is what?
One 20.
One what?
Plus
20.
Then
225.
225.
Yes.
Okay. So I need you to choose the task you're going to pick. Number 1. Somebody must help us draw a scatter diagram.
sorry, the summation of y should be 29.
Summation of y 29. Okay. So one will lead us in drawing the scatter diagram. The other one predict the regression equation. Okay, then the other one will help us find r and r squared and interpret. Okay, so you pick your tasks quickly. Okay, then also predict what? Predict y if x is what? 10. Okay, these are easy tasks. So let's start with call this exercise. Let's do this exercise quickly. Okay. So we'll start with drawing the regression equation. Are you able to see? Able to see?
Yes.
Okay, so you're drawing the highest value is 10 on the y and the highest value is 8 on the x. You draw to scale. You can illustrate it in the way you're able to. So here and there. So we have 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. I have 0 here. 2, 4, 6, 8, 10. 2, 4, 6, 8, and 10. So what are the first coordinates we have? 2, what? 10.
2,10.
So 2, 10 somewhere here. Next. 4, 6.
4,6.
Here. Next. 6, 8.
6,8.
Here. Next.
8,5.
8,5 here. So what does this tell you? Is it positive or negative? What can it tell you? Is it a positive or a negative? It's down sloping, so it's a negative and strong. The dots are closed, right? It's negative.
Yes.
Okay, who can remember the regression formula? Y is equal to what?
To A plus BX, is it?
Plus BX, yes.
A plus BX.
Okay. So we first remember how to find our A and B. So our A, we can find A after finding our B. Our B is what? Sum of square xy over sum of square xx. And our A will be sum of y over n minus b sum of x over n. Okay, so it's easier. First we find all the sums of xx and yy. If anyone can remember, how do we find the sum of xx? Sum of xx is x is throughout, right? Summation of x squared
X
minus
throughout.
summation of x to the power 2 over n. Okay. Then here, summation of yy. Who remembers? Summation of y.
Summation of y squared. Then summation of y, yeah, over n.
Then xy. Summation of xy here minus summation of x in brackets summation of y over what? Over n.
N.
So our n, how many pairs we had here? We had 4 pairs.
There are 4, is it? 4 pairs.
Yes. So our n was 4. Our summation of x was 20.
Yes.
Our summation of y
It's 29.
29. Okay. Xy was 132. Summation of x squared was 120. And summation of y squared was 225. So I want you now to substitute this. Try to substitute this in these ones here. When you do the calculations, these are the figures you find as xx, yy, and the xy. So remember to find our b, it is xy, which is negative 13, over xx, which is 20. So we will go to substitute our b. Let's go to our b. Substitute.
B is here. That's y summation.
So it is negative 13 over what? Xx. So we have xy, which is negative 13, over xx, which is 20. What are we getting? Negative 0. What?
0.65.
Cool. Okay, so where there is y, we're going to put what? A, we don't know yet. Where there's y, we put
0.65.
Okay, the negative will make it so negative 0.65. Okay. X. Where there is A, the formula for A, summation of y over n. What was summation of y? 29?
29 over 4.
4. Then the B, which we have found, which is negative 0.65. Then summation of x was what? 20 over 4. So 20 over 4 is 5. 5 times that.
So it's what? Negative 3.25. 3.25.
So the negative and the negative become positive, right?
Yes.
Then when you add them, what we get?
10.5.
10.5, good. So where there's A here, we put 10.5. So our regression equation will be what? Y is equal to 10.5. Y is equal to 10.5 minus what? 0.65x. Okay, then we are told if x is 10, what is y? So let's substitute. If x is 10, where there's x, we put 10. What are we getting as y?
Okay. 10 times 165. It is 10.5. 4.
Before, yeah. Okay. Then now we are going to find the R and R squared. The R and R squared. Who remembers what does R stand for?
Coefficient of correlation.
Yes, good. So R is coefficient of correlation. It is given by xy over square root of xx times yy. So our xy was what? Negative 13. Our xx was what? 20. And our yy, our xy was 20. Our yy was 14.75. So 14.75. What are we getting? So you just multiply these two, then square root them, then divide them into 13.
Point 757.
0.757.
757.
757. Okay. So this means there's a negative relationship because we've gotten a negative. How about if
Okay.
you square it? It's called coefficient of determination. What are we getting?
0.57.
0.57 what?
3.
Okay, what does this mean? It means 57.3% of the variation in X. It means 57.3% of the variation in Y is as a result of the variation in X. 57.3 of the variation in Y is as a result of the variation in X. Or we can simply say 57.3% of Y is influenced by X. Okay. So this is what linear regression is all about.